Rational Inequalities Part 2. Solve the rational inequality and graph the solution set on a real number line. Express the solution set in interval notation. Here I have a rational inequality, and as you can see, I have a single expression on the left and a 0 on the right. The numerator is already factored and the denominator is also already factored. So I can go ahead and set the numerator equal to 0 and the denominator equal to 0. Since I have two factors in my numerator, I can go ahead and separate those and set them each equal to 0. So I'm going to go ahead and solve, and I have x equals negative 12 and x equals positive 14. And these are two of my boundary points. Since I have a equal to sign underneath my inequality sign, I know that these 2 points are included, so I'll write those within brackets when doing my intervals. Now I have x plus 10 equals 0, and this represents the expression in the denominator. So x equals negative 10 is a boundary point, but since it's in the denominator, I know that I can't have x equaling a negative 10. This is still a boundary point at x equals negative 10, but this is not going to be included in my interval. So I'll place parentheses by the negative 10 instead of brackets. Now I'm going to just plot these boundary points on a number line and create intervals. So my first interval is negative infinity to negative 12, and negative 12 is included. My second interval is negative 12 to negative 10, and the negative 10 is not included. Then I have a third interval of negative 10 to positive 14, and a fourth interval of 14 to positive infinity. Now we'll take each interval, choose a test point within the interval, and then test it within our original inequality. The first interval is negative infinity to negative 12, and I chose x equals negative 20. So you just take negative 20 and plug it in wherever you see an x in the original inequality. When we simplify this, we get negative 8 times negative 34 divided by negative 10. And that reduces to 272 divided by negative 10, which is the same as negative 27.2 is less than or equal to 0. Now this is a true statement. Negative 27.2 is less than or equal to 0. So I know that this interval is going to be a part of my solution. Next, we'll look at the second interval of negative 12 to negative 10, and we'll choose x equals negative 11 as our test value. So I plugged in negative 11 into the original inequality, and we have 1 times negative 25 divided by negative 1. This simplifies to negative 25 divided by negative 1, which is a positive 25. Now positive 25 is not less than or equal to 0, so this interval will not work. Next, we're going to choose the interval negative 10 to 14, and I'll choose x equals 0 as my test value. So I just plugged in a 0 wherever I saw an x in my original inequality. That reduced to 12 times negative 14 divided by 10. 12 times negative 14 is negative 168, and that's divided by 10. When I do that, I get negative 16.8 is less than or equal to 0. Now this is a true statement, so that means that the interval negative 10 to 14 is included in my answer. Lastly, we'll look at our interval 14 to positive infinity, and I'm going to choose x equals 20. So I plugged in a 20 wherever there was a 0, and we have 32 times 6 divided by 30, When we simplify that, I get 192 divided by 30, which is approximately 6.4. And 6.4 is not less than or equal to 0. So that interval will not work. We had two intervals that when we tested a value between those intervals, it worked for the inequality. So we have two intervals that are a part of our solution. So our answer is negative infinity to negative 12 and negative 10 to 14. Since both of these intervals are included, I'm going to use a union sign to write my final answer. And this is my solution in interval notation.